Welcome. I'm Anu from Hewlett-Packard, and I'm a senior engineering manager with the cloud operations team. This presentation is based on our experience with operating a public cloud running OpenStack. We operate OpenStack at scale across several thousand nodes. And this is based on how the CMDB has been so critical to efficient operations of OpenStack at scale. Why do we need a CMDB? A CMDB is critical because it bridges a gap in OpenStack wherein there is no tooling around managing physical assets and linking them back to the services deployed. So basically, this provides a single pane of glass for data from OpenStack services, from your ops tools, your networking tools, your configuration management tools, your provisioners, name it, but it brings it all together and provides a single pane of glass across them and across OpenStack. And this is super critical for troubleshooting. It's optimized for managing OpenStack data centers. So it includes supports for diverse virtualization technologies, KVM, VMware. It's aligned with OpenStack in terms of visualization in the Horizon UI. There is out-of-the-box OpenStack services support. It's super useful for security compliance and audits, and accurate data for capacity management and allocations. So all in all, this has been a must for us to operate OpenStack at scale. How does the CMDB work here? The CMDB that we have in public cloud HP is codenamed Socorro, and it is basically an aggregation engine that brings in this data from diverse providers, including OpenStack services, your provisioner, your allocations, allocations meaning who owns what, your virtualization technologies, your inventory, what assets, and where do they live, and any other info you have about that node. And consolidating all this data into a single non-relational database in this case is that it ensures that the data is 100% accurate and syncs up, and it ensures that if you have a data center operations team, that they can be dispatched to the exact location where there is a problem. A simple query can be used to highlight and find nodes of any particular type to host services. And we have also developed a system wherein we have asset scans of our hardware, and this makes it possible for us to do periodic scans and ensure that the asset data is 100% accurate. There's automatic consistency checks across the data from the different sources, and there's also automated consistency fixes for the data. And there is periodic reporting for the errors that cannot be automatically fixed, so that operations teams can ensure the data is fixed. And the linkage from the physical to the logical is the super important factor here, because it's possible then to do queries like, tell me all the Nova instances that are connected to this particular network router that just went down. So that is traversing from the logical Nova instances to the host info, and then finding out what network hardware is linked to it. So that is the power of this aggregation. Data feeds to other systems are potentially possible for additional reporting and other use cases. This has greatly reduced the risks with targeting destructive ops at the wrong systems. For example, if a particular system is supposed to be reimaged and operations does a quick query and finds out that there are actual customer instances running on that node, then that's immediately flagged and stopped at that stage. So really mitigates the risk there. Timely intervention for incidents is possible because a customer reports a problem, you're able to quickly trace it down to the physical layer and then troubleshoot at that layer if needed. Allocations, again, are made more accurate by the data that's aggregated. So what is the one key problem that this is solving? Basically, we look at it this way. There is encapsulation of OpenStack and its services and tools. And there is a set of data that resides in this encapsulation. And then there is the operator environment, and there is the traditional IT set of tools. Again, in the traditional IT landscape, it's not uncommon to find tools like the CMDB. So what's the distinguishing feature here is that the CMDB that we use in this public cloud space for operating OpenStack bridges this gap that exists between this encapsulated OpenStack space and the traditional operator environment, and brings the data together across these two environments to paint the entire story. I would like to allude to the story of four blind men looking at an elephant, not looking at it because they were blind, but trying to figure out what an elephant is. And depending on which portion of the elephant any one of them were touching, they came up with a completely different story of what the elephant was. And that's how the different operational teams today look at the data. There's the network team, there is the systems team, there is the data center ops teams, and they all have a different view of it. And then there is the services teams. So putting it all together in Socorro, in our CMDB, really tells the story by bringing the data together. At this point, I would like to talk about the data sources and how, especially in the asset scanning space, we had to innovate and come up with a neat new mechanism for asset scans. So what is shown here is a pictorial view of our asset scanner. And with this, you're basically able to go in and scan racks, scan your nodes or your network routers or your storage hardware in the racks. And this not only lets you keep a really accurate inventory of what hardware you have, but also where it resides. And again, the picture there shows how a typical data center looks like, a rack looks like, with the jumble of wires. And it is, even though this is such a simple solution, this is critical for bringing in the reliability of your data. And harmony is the aspect in Socorro where the CMDB, where when we put in all the data together and fix the errors and then report on the errors that cannot be fixed, so that operators can come in and validate and fix them. This is the horizon-based view of Socorro, and this is a picture of the entire data center as painted by the CMDB, and it shows the rows of racks, and you can click on any one tile as shown in the first graphic there, and then that brings up a pictorial view of how the actual rack that's located on the tile, and then you can see instantly the different nodes at the different positions in the rack, and you could also see right there that there are empty spaces in the rack, potentially because of cooling considerations, etc. And at a glance, you can spot the mix in the rack in terms of the number of routers in there, the number of server nodes in there. You can mouse over any one of those routers or nodes and get additional info about it. Clicking on any particular node would give you the aggregated data from the different providers of data for that node. Example, in public cloud, we use Chef for deployment, and so it would list all the Chef roles that were applied to this node. And right away, you would see that would have a Nova role and or a Neutron role. And another unique thing to point out there is that we also report on when the last data collection was done for each of the providers, so you can see how what's the timestamp associated with each of the data pieces in there. And they could all be at different intervals, so the scans could be less frequent than the Chef collections, and we could be collecting from the networks a lot more frequently than Chef, for example. And though it's not visualized in here, another key piece of the value that brings is that you would be able to see the data from the service, for example, Nova, and then if this particular node in a particular rack was hosting Nova instances, you would be able to see at a glance that those instances reside on that node. And for example, if you know there's a problem going on in the data center, wherein there is a problem with a particular rack, then you can quickly just mouse over and collect information about the nodes that are carrying a customer workload. And this is super powerful in terms of then turning around and notifying the right customers within a period of minutes about the impact that they're potentially going to see with this particular node failing. In summary, the Socorro CMDB that we have deployed in public cloud is an aggregation engine that brings in data from the traditional IT sources like the network, your assets, and then ties it together with data from your OpenStack services and provides a single pane view in horizon-based for viewing that data. And this has been super critical for us for studying customer impact and for troubleshooting purposes. If you're an operator out there running OpenStack in scale, do reach out. We would be glad to collaborate with you and share more and talk about what this has brought us. So my email is out there. Thank you for watching. Thanks, bye.